Okay, so my name is Evan Macknick. I work as a site reliability engineer at UShip. So basically keeping all the things alive as it would be. I want to talk first a bit about a little bit of background on this and kind of where the idea came from. So about 2 years ago, we started a move from our on-premise infrastructure to the AWS cloud. And when I say 2 years ago, it means, we started, looking at requirements of the web servers and decomposing them. We had basically a bunch of them that were kind of composed by hand. And each one, we had a mix of 2008 R2 Windows machines and 2012. So it kind of, it was a big undertaking just to figure out what we needed. And then we kind of went from there. And we kind of got to the point where we had, basically three requirements or, three kind of ables as it would be. So, while we're building this, we want it to be repeatable, configurable, and scalable. And really that's one of the big things you move to the cloud for is so you have that flexibility to be able to scale up and down as needed. So I'm going to talk mostly about the repeatable and configurable part of that because the scalable kind of comes with the other stuff after you've implemented that. So our requirements for repeatable stuff. We wanted to do artifact deployments, and this was a big one. So our previous system was basically, file copied and stuff of that sort. We have a large monolithic .NET app, multiple gigs, I think like 3 gigs or something like that. Thing's huge. And so we wanted to be able to deploy that as an artifact so that we'd be able to deploy that to different environments and stuff like that. So we can deploy to dev, QA, sandbox, production, any number of environments with the same exact artifact every single time. We also wanted to be able to, kill these machines as we needed without having to worry about with the environment. We want to have that, be able to repeat that need. So in terms of durable, the one thing, like most applications, we have different settings for environment. So, different sets of API keys, it's, a whole bunch of different configuration. And there may be more configuration in production versus dev or whatnot. So that's a concern. We also need to be able to do the configuration at runtime. So while I say, we're doing AMI deployments, we still need to be able to, doing an AMI deployment, we kind of got to like, well, how do we serve up that configuration when we start up that server? Because we can't obviously have dev, settings in production or something like that. So. And then scalable, we want to be able to adjust traffic, based on the traffic. So that's kind of a given. And we have different needs in terms of actual infrastructure for our environments. So we only need a couple of servers for dev typically, but production's gonna, have, a significant number based on how many users we have at any given time. And then QA is gonna have a different one as well. So that was the other concern there. So let's talk about the repeatable part of this. And this is kind of where we get into the Packer and Chef and how those work. So granted, there's, different ways of doing this, but, for our case, we decided to kind of do a layered approach to the AMIs. So we have basically a base AMI, and that sets up things, that, your typical, everything's, maybe shared across different, higher layer AMIs. And then we also have an application AMI. And what that does is basically just pulls down the application that is built as an artifact, and then bundles that all into an AMI, and that AMI is what actually gets deployed onto the actual servers. So I'm going to kind of skip the upper part of this Packer template basically, and kind of get more to the provisioner. So the builders, if you want to go check out the documentation for the EC2 builder, that's kind of what we use here. But the provisioner, so this is the thing that kind of makes a difference. So this is, basically a cookbook that, I said it has things like, shared across all of your different servers. And this one uses Burkshelf, which is kind of the, if you've used Chef, it's going to be more of like the older way of packaging your Chef dependencies. But the reason for this is that it gives you the ability to vendor all of those dependencies. And so those all get uploaded to the Chef or to the Packer instance as it's being created. And then it resolves all those dependencies from those files that are vendored there. So that's kind of the caveat there. So let's talk about the Chef recipe. I said, this is going to include things that don't typically change very often. So, it might be things like security patches, maybe packages for the operating system. This is also where we're going to actually install Chef Habitat. And the main reason for this is that, it kind of gives you a nice interface for doing that. So from SSM, right? And then we're also setting origin environment variable. Basically going to authenticate us to what's called the habitat, and that's kind of the okay. So then we use the hab install resource to actually install Habitat, and we're going to accept the license. And then habsup is another resource that basically sets up the what's called the Habitat supervisor. And the supervisor is a thing that manages the actual Habitat services. And if you can see, the auth token part is where we're actually taking that hab token that we pulled down from SSM and we're lazy loading it. So we're doing this computation at Chef runtime versus when it puts all the resources together and figures them out in the beginning, it's going to wait until it gets that value. So that's a key there. So then we also have, so we're using doing an application AMI based on the base AMI. So I've left off the part, but basically we're using the source AMI is our base AMI that we just built, okay, from that Chef cookbook. And this is basically what we're doing here is we're going to drop the PowerShell file on there for basically that sets up our artifact. And then in the next part, we're going to call an inline PowerShell script to basically call that PowerShell file. And you see we're passing in also the Git SHA. So it's, this template would take a variable basically. So here's the PowerShell file, the setup artifact.ps1, and you see, so this one's getting it from Artifactory. I mean, you can use any artifact storage location you want, but see how we're doing the Git SHA. Basically, we tack that onto the end of it as we kind of search and find basically whichever one we want. So you can kind of deploy any Git SHA that you've built already. And you can see we're using the chocolatey version of curl. It's significantly faster if you've ever had to deal with that. But then, basically we download that and extract it to the location where IIS is going to serve that. So while this is kind of Windows specific here, the idea, the concepts of pulling these artifacts down is can be the same depending if you're on Linux or whatever. So this kind of gets us into the configurable part of things, and for that's where we're going to leverage Chef Habitat. And see, we'll talk a little bit about what Habitat is. So Habitat is Chef's kind of way of packaging up applications from the application's focus versus like Docker, where you're building things up from like the OS level still, right? Or the infrastructure level and then putting application on top of it. This is kind of like, what do you need to, for your application to run? And let's grab just that, okay? So Habitat provides you what's called the Habitat Studio, and this is a clean room environment. So it basically just, there's, to So it also provides, so all those dependencies are actually at build time. So you have your run, your build, those are all locked in. Everything ships with that app. And then you can actually export this to run on, you know, any platform you want to. So you could export this to run on Docker. Granted, you know, in our use case, we're doing, or like in a .NET use case, if you're doing something like classic .NET, you kind of have to run on Windows. If you're doing .NET Core, you can kind of go onto different platforms. But the classic ones kind of need underlying IaaS and .NET infrastructure. And so it also provides, so that's kind of the build, those previous things were kind of like the build part. Habitat also runs on your actual servers and has a what's called a supervisor to do management of the other Habitat services that are running, and also things like configuration for those services. And it also provides you the ability to rolling updates across your entire fleet. So if you want to push an update, the supervisor is going to talk to the other supervisors, and it's going to kind of roll out those updates without you having to really worry about it too much. So now that we've talked a little bit about what Habitat is, let's talk about the effortless infrastructure part of this. And that's a term that's kind of coined by Chef. But what it does is basically leverages Habitat for your Chef cookbooks and runs them as an application. So the nice part about this is you have no Chef service. I don't have to worry about setting that up. If you've ever used Automate before, you can report to Automate, but it's a lot less overhead. It also provides automatic updates, and this is a cool thing in that once you package up and push your package up to the builder service, you can automatically your cookbook will automatically start running those the new version. So real quick, so we have the previous cookbook for the base AMI. We're gonna have a cookbook that's more focused on what the application actually needs to run. So this would be something I'm not gonna really go into this here, but because it's kind of more specific for individual needs. But it's going to be things like IaaS configuration, sites, and stuff like that, or per environment settings. If you're dropping, let's say you're sending stuff to like your logs to one location for production versus dev or whatever, and so you can kind of just configure that stuff here. So I said it's more kind of based on what the application needs to actually run. And then here we're also going to use policy file, not Berkshelf here, and the reason for that is that the effortless scaffolding for Habitat leverages the policy files. And policy files, while I'm not going to get into too much there, is kind of a newer way of instead of Berkshelf, policy files will do the dependencies, and it kind of replaces roles and environments if you're used to that with kind of the classic Chef stuff. So once we have our actual cookbook set up, we're going to initialize Habitat. And doing this, you basically just do hab plan init. That creates kind of the default files for you. So the ones we're kind of worried about here are the plan.ps1, which is called the Habitat plan, and also the default.toml. So all the Habitat's configuration is done in TOML. So we'll take a look at the plan real quick. Plans are written in either Bash or PowerShell, depending on which system you're on. So it's nice because if you're a Windows developer, you can kind of pick up and start writing your Habitat plans in PowerShell very easily. So the first part is pretty self-explanatory. I mean, basically just package name and the origin. The origin is kind of like you the second part where what's important. So we're pulling in the package scaffolding, and basically it does all of the heavy underneath the hood. You don't have to worry about that. You can obviously go look at the scaffolding and see what it's doing. If you were curious about how it's actually built, but it's all of this scaffolding you can kind of leverage it. Policy name, so that's the policy file and where that policy file is actually located. So typically policy files are located in the just directory with your cookbook. So you can, so that's basically where this one says. And I'll have links to the code that I've used for this. So the Habitat config, I said, it's done via toml files. We basically just need a little bit of configuration for the Chef client. Just tell it, it's going to run every 5 minutes with an offset. That's what the display setting is. And basically, so it's all documented there. It's pretty easy. But then, so after you've written that, we can actually build the cookbook. And see what happens. So the hab package build, command is just going to build in the dot is basically the path to where the Habitat directory is. So what that does is it actually brings up that clean room studio, pulls all the dependencies and generates your signed artifact. And each one of those artifacts you can see is it's got basically a timestamp on the end of it. So while you do have the version there, you've also got a timestamp. So you can keep generating these and push out newer ones of the same version if you wanted to. So after we've got that built, what we'll do is we'll basically upload that to the Habitat Builder service. Okay, so basically we're just setting the first line basically just sets the variables. See with that package artifact variable that gets set from the first line, and basically just uploads this. So if you go to builder.habitat.sh, you look at the uship and web server, you can see there's a couple of different versions there. So that's where this lives, and that's basically where Habitat's going to pull from on your actual servers. So to install the uship, the web server Habitat package, we'll basically just do hab package install, and see uship is the origin and then the name of the package. You could also add the version string on there if you wanted to lock it to a specific version. And then to load the actual service and get it running, you do hab service load, the name of your package, and then strategy at once basically tells it how I want it to update. So if you just load it without strategy and push out new packages, it's not going to update it by default. So this tells the supervisor to basically watch for new versions, and it'll go ahead and pull versions automatically. So if we want to do this with our AMI, we can do this, via the AWS console. Basically, just load this in as user data. So we've got that application AMI that's already got our application code on there, and then we can use our user data to install the uship web server package, and when it boots up, and that will go ahead and further configure IAS and stuff of that sort afterwards. Or we can also Terraform it, and this is where you kind of get into an easy way of pulling the AMI, right? And then loading all that PowerShell user data there. So it's even easier. But as I said, we want to be able to configure different environment settings. So how do we do that? Using this way. So at uship, what we've kind of taken advantage of is separate AWS accounts. This is kind of simplified things. One of the ways, and so while it does simplify some things, granted, you have to share AMIs across your different applications. That's pretty easy, but it does, it's simple. It makes SSM params easy. So we're leveraging the systems manager parameters to be able to do some of that dynamic configuration. And we can name everything the same in each account, right? And it just automatically, whichever account it's in, it's going to automatically pull that variable. So you don't have to do any kind of conditional variable names or anything like that. It's kind of nice. So let's say we pull the SSM param, we can go ahead and set the environment variable in user data. Okay, so things like, let's say you want to push all your metrics to Datadog, you don't want to, but you need to set your key differently in prod versus dev or whatever. You could do that via environment variables, and if you're reading that in your Chef code, then it'll go ahead and sub that in there when Chef runs. And I said conditions in the Chef code, so basically you can, let's say like there's one part that I've done where, you're setting the Chef environment, to production. And so I can write, if blocks in the Chef code to only run certain parts if that environment variable is available or something like that. So, So how does this all work in kind of like a pipeline scenario? Let's say you go ahead and build your base AMI, right? After that, you take that AMI and build an application of AMI, okay? Then you go ahead and package up your Habitat cookbook. Granted, you could probably do this in parallel if you wanted to, and deploy that to your builder service. So then you're going to deploy your application, installing that package in the user data. Then you can push updates to the Habitat package, and using that channel, it's going to automatically pull the running Chef again. I mean, it's nice. You don't have to worry about, push jobs or, trying to anymore. It just automatically picks up those. Okay, so some of the resources aside from, Packer, I've got a couple of blog posts too, and the code is the third right there. You can check out about Habitat and policy files. And then the last one is a YouTube video for actually, working with the Habitat infrastructure, and that's from Chef. So I definitely check that out if you're interested in how to run your cookbooks in this way. And the other thing is, let's say you can kind of take this even further into like auditing, and they have inspect in a way to do effortless inspect. So you can run, basically your Habitat code or your Chef code and your inspect code, both as applications on your servers using Habitat. It's nice. All right, any questions? So I do see a question in that has kind of answered this. So I did use policy files and Burkshelf, and the reason that I went with Burkshelf for the base AMI is that it kind of, I mean, for our cases, it worked a lot better with running Chef solo versus trying to trick Chef or leverage it in using Packer. The Chef solo stuff is dead simple. When you start getting outside of Chef solo with Packer, it gets a little harder to deal with.